Exercise 8.3 of Mathematical Methods by S.M. Yusuf. In this exercise, apply the ratio test to determine whether the given series converges or diverges. From question number 1 till question number 10, you have to use the ratio test here to determine whether the given series are converging or diverging. For that purpose, you must know that what exactly ratio test means. That is given on page number 349 of your book, the ratio test, or you can also name it as D'Alembert's test. In this test, the given series of the positive terms, and suppose that let this series, that whatever series is given in your question, take this an, put in place of n plus 1 and find out an plus 1. Divide that an plus 1 with an, apply the limit n approaches to infinity on that, you will get some answer here, where this L is a non-negative real number or infinity. What does this non-negative means? It means it is not a negative number. Not a negative number means it could be positive or it could be 0 as well. Not all this L are positive, because 0 is also included in this L. Due to the including 0 here, they have written here non-negative. Now, you have to observe this answer L. If L is less than 1, then this means that your given series converges. And if L is greater than 1 or infinity, then your series is diverging. And if L becomes equals to 1, then this ratio test will fail. And you have to move on some other test. And you have to apply some other test here now. Now this ratio test is easier as compared to the previous test, because in this test you directly have to divide an plus 1 an and apply the limit on it, and you will get some answer and you will observe that answer according to these postulates. This test is relatively easy to solve as compared to the limit comparison test or the simple comparison test or the others divergence test as well. Let's just solve. Start from question number 1 of this exercise. Summation 0 to infinity 2n over 2n factorial. Here your an is 2 raised to power n over 2n factorial. Find out an plus 1. Now you have to replace your n with n plus 1. So this will become 2n plus 1 divided by 2 into n plus 1 and this main factorial. So this will become equals to 2n plus 1 divided by 2n plus 2 factorial. Now apply the limit n approaches to infinity, an plus 1 divided by an. This will become equals to limit n approaches to infinity 2 raised to power n plus 1 divided by 2n plus 2 factorial. This is an plus 1 divided with an. So division an is 2 raised to power n over 2n factorial. Change this division sign into the multiplication. You will get here limit n approaches to infinity 2n plus 1 divided by 2n plus 2 factorial into 2n factorial divided by 2n. Now simplify the terms. Before applying the limit, you have to simplify the terms. You see here this 2 raised to power n plus 1 can be written as 2 into n, 2 raised to power n into 2. And this factorial can be opened up and every consecutive terms is subtracted with 1. If you move on the right side, it will become 2n plus 2 into 2n plus 1. You are just subtracting 1 and 2n. Stop here. The term at which you have stopped, just write the factorial with that term. Why I stopped here? Because I see, you see we have here this same term and we can cancel them with each other. That's why I stopped till here, 2n. Now I can cancel these terms, this one with this one. So I am left with limit n approaches to infinity 2 over 2n plus 2 into 2n plus 1, this one. Now apply the limit n approaches to infinity here. If you apply the infinity here, 2 over infinity will give you 0, this thing. So the whole term will converts to 0, and you know that 0 is less than 1. So this means the given series diverges. The given series, no, if it is less than 1, then this means that it is converges. The given series converges by the ratio test. So you see, this ratio test is easy to apply. But the one thing that you need to be conscious with, that you must know that how to open the powers and how to open the factorials. Then you can easily just figure it out, that what will be the ending function, and then apply the limit. So if you observe, mostly the functions, if none of the test is given on the top of your question, that whether you can apply any test to check the convergence or divergence, then if your function an has some power and it has some factorial, then this is a key to understand that you must use the root test or ratio test here. You must use the ratio test here. If you have some powers of an and you have the factorial in it, then it is easy to solve that kind of questions using the ratio test. Now question number 2. Summation 1 to infinity n factorial over n raised to power n. Here your an is n factorial over n raised to power n, and an plus 1 is n plus 1 factorial divided by n plus 1 into n plus 1. Just replace n with n plus 1. Now apply the root test here. Limit n approaches to infinity, an plus 1 divided by an will be equals to limit n approaches to infinity, an plus 1 is n plus 1 factorial divided by n plus 1 or power n plus 1 divided with an. An is n factorial over n raised to power n. Now simplify these terms. You will get here limit n approaches to infinity, n plus 1 factorial over n plus 1 raised to power n plus 1 multiply with n raised to power n over n factorial. Now if you observe, this is n plus 1, one more term than this one. So just open this factorial. You will get here limit n approaches to infinity, n plus 1 into n plus 1 minus 1. You are moving on the right side, you are opening this factorial, so you need to subtract 1. So you will get here n factorial divided by n plus 1 into, you can also open this term. Let's just open this term. You can open it like n plus 1 raised to power n into n plus 1. And here you will get n raised to power n over n factorial. This n factorial can be cancelled out. This n plus 1 will be cancelled with this n plus 1. So you will be left with limit n approaches to infinity. Here you will get n raised to power n over n raised to power n over n plus 1 raised to power n. You can write it like n raised to power n over n plus 1 raised to power n. So it can be written as limit n approaches to infinity. This thing can be written as 1 over n plus 1 raised to power n divided by n raised to power n. It can be written like this. So it will become limit n approaches to infinity, 1 over n plus 1 over n whole raised to power n. So it will become limit n approaches to infinity, 1 over 1 plus 1 over n raised to power n. Now apply the limit. This is a special function, and you know that its answer, when you apply the limit n approaches to infinity on it, its answer is e, exponential. That is, you will get here 1 over e. And you know that you can solve it using calculator. You will get here the answer less than 1. So it means the given series converges. The given series converges. So this is the answer for your question number 2. Move on to question number 3. You will get here question number 3. Here an is this whole term. An equals 7 raised to power n over n into 5 raised to power n plus 1. And an plus 1 will becomes 7 raised to power n plus 1 divided by n plus 1 into 5 raised to power. Here you will put n plus 1 n plus 1 and this plus 1 as it is. So you got here 5 raised to power n plus 2. This is 7 raised to power n plus 1 divided by n plus 1 into 5 raised to power n plus 2. Now limit n approaches to infinity, a n plus 1 divided by a n will give you limit n approaches to infinity. A n plus 1 is 7 raised to power n plus 1 divided by n plus 1 into 5 raised to power n plus 2 divided with a n. A n is 7 raised to power n over n into 5 raised to power n plus 1. Now simplify the terms. You will get here limit n approaches to infinity, 7 raised to power n plus 1 divided by n plus 1 into 5 raised to power n plus 2. This 5 raised to power n plus 2 can be written as 5 raised to power n plus 1 into 5. I just separated 5 raised to power 1. Multiply by n into 5 raised to power n plus 1 divided by 7 raised to power n. Why I opened it? Because you see we have the same function here, so we can easily cancel out it. Also, if you observe, we can make 7 raised to power n here. Just split its power, you will get here this term. Now you can cancel these terms with each other. You will get here limit n approaches to infinity, 7 over 5 into n over n plus 1. Now it can be written as limit n approaches to infinity, 7 over 5 into, move this n down here in the denominator, divide it, you will get here 1 over 1 plus 1 over n. And if you apply the limit here, this term will goes to 0 because 1 over infinity will give you 0. So from here you will get 1 in your answer. 1 into 7 over 5, you will get 7 over 5. And you see this is greater than 1. So this means the given series diverges, because the answer for the limit is greater than 1. An here is n over n square plus 1 and an plus 1 is n plus 1 divided by n plus 1 whole square plus 1. If you open it, you will get here n plus 1 divided by n square plus 2n plus 2 after opening this square formula. And you know that what is the formula for square? A plus b whole square is a square plus 2ab plus b square. Using this formula, open it and simplify it with plus 1, you will get here n square plus 2n plus 2. Now apply the ratio test here. Limit n approaches to infinity, an plus 1 divided by an. This will convert into limit n approaches to infinity, an plus 1 is n plus 1 divided by n square plus 2n plus 2 divided with an. And an here is n over n square plus 1. Now just change this division sign into the multiplication. You will get here limit n approaches to infinity, n plus 1 divided by n square plus 2n plus 2 multiplied by n square plus 1 divided by n. Now you can just separate it like limit n approaches to infinity. Move this n down to this one. You can write it like n plus 1 over n into n square plus 1 over n square plus 2n plus 2. You know that if A is multiplying with B, you can write it like B multiplied by A as well. So I just switched their positions. Now it can be written as limit n approaches to infinity. This term can be written as 1 plus 1 over n. Take n square common from the second term. You will get here n square 1 plus 1 over n square divided by, also take n square common from the denominator. You will get here 1 plus 2 over n plus 2 over n square, like this. Cancel the terms. Now apply the limit. If you apply, 1 over infinity will goes to 0. 1 over infinity will goes to 0. This term will goes to 0. This term will also goes to 0. So you will get here 1 plus 0 into 1 plus 0 divided by 1 plus 0 plus 0. So here you will get 1. Now the ratio test is failed here. So you will write the ratio test fails. Now this test is failed, So we can use the some other test here. I am using here the comparison test. What is your an? Our an is n over n square plus 1. We can just select the bn. How? You know that n square plus 1 is greater than n square. And you know that if you take the reciprocal, 1 over n square plus 1 will be less than 1 over n square. And we need here n as well. Multiply n on both sides. You will get n over n square plus 1 will be less than n over n square. And this thing is equals to 1 over n. So this term is your bn here. So you will write it bn equals to 1 over n. And you know that summation 1 over n, that is your bn, is divergent harmonic series. So it means just it can have the same behavior with the an if we just check its limit by using the limit comparison test. Apply the limit is divergent harmonic series. Now limit n approaches to infinity an over bn, because if this limit is defined limit, so it means that whatever the behavior you are getting from this bn, that will be the same behavior for an. Now limit n approaches to infinity an over bn will give you limit n approaches to infinity an is n over n square plus 1 divided by bn, and bn is 1 over n here. So this will give you limit n approaches to infinity n square over n square plus 1. Take n square common and cancel the terms. You will get here 1 over 1 plus 1 over n square. And this will give you 1 in your answer. So it means whatever the behavior you're getting from this series, the same behavior will be for an. Since summation bn diverges, since this series diverges, this implies that your an also diverges. Now move on, question number 5, that is summation 1 to infinity 2n factorial divided by 4 raised to power n. An here is 2n factorial divided by 4 raised to power n, and an plus 1 is 2 into n plus 1 factorial divided by 4 raised to power n plus 1. This can be written as 2n plus 2 factorial divided by 4n plus 1. Now limit n approaches to infinity an plus 1 divided by an will be limit n approaches to infinity 2 into n plus 2 factorial divided by 4 raised to power n plus 1 divided with an. This will give you 4 raised to power, after simplification will give you this step 2n factorial. Now I can make the same terms so that I can cancel them. Limit n approaches to infinity, it can be 2n plus 2 into 2n plus 1 into 2n factorial divided by 4 raised to power n into 4. And here you have 4 raised to power n over 2n factorial. This 2n factorial cancel. This 4n is cancelled. So we will be left with limit n approaches to infinity an plus 1 divided by an will give you limit n approaches to infinity 2n plus 2 into 2n plus 1 divided by 4. After applying the limit, you will get here some undefined answer. It means the given series diverges. Diverges by using the ratio test. An is 2 raised to power n over n into n plus 2, and an plus 1 will give you 2 raised to power n plus 1 divided by n plus 1 into n plus 1, n plus 2 will give you n plus 3. So using the ratio test, limit n approaches to infinity an plus 1 divided by an will give you limit n approaches to infinity 2 raised to power n plus 1 divided by n plus 1 into n plus 3. And after simplification, you will get here n into n plus 2 divided by 2 raised to power n. So you will get here limit n approaches to infinity. This 2 raised to power n plus 1 can be opened as 2 raised to power n into 2. And this 2n and 2n will be cancelled. So you will be left with 2 into n plus 2 divided by n plus 1 into n plus 3. Now you can write it like limit n approaches to infinity. Just take n common from here. You will get here 2 n square. This n, if taken outside, this will multiply with this n. You will get here n square. And here inside will be left with 1 plus 2 over n. Now take n common from the first bracket and the second bracket as well. Both after multiplication will give you n square. And you will have with here 1 over 1 plus n into 1 plus 3 over n. This n square and n square will be cancelled. So this will be limit n approaches to infinity 2 into 1 plus 2 over n divided by 1 plus 1 over n into 1 plus 3 over n. Now apply the limit. This term will goes to 0, this term will goes to 0 and this term will also goes to 0. So you will be left with 2 into 1 plus 0 divided by 1 plus 0 into 1 plus 0. So here you will get 2 and this is greater than 1. So the given series diverges. The given series diverges by ratio test. An is equals to n plus 1 into n plus 2 divided by n factorial, and an plus 1 is n plus 1. Here in place of n replace n plus 1 and this plus 1 will come as it is. This replace this n with n plus 1 and this plus 2 will come as it is, divided by n plus 1 factorial. So it will become equals to n plus 2 into n plus 3 divided by n plus 1 factorial. Now using the ratio test, limit n approaches to infinity, an plus 1 divided by an will give you limit n approaches to infinity n plus 2 into n plus 3 divided by n plus 1 factorial into n factorial divided by n plus 1 into n plus 2. This n plus 2 and n plus 2 can be cancelled out and will be left with limit n approaches to infinity n plus 3 divided by. Now I can write this n plus 1, open this n factorial, you will get here n plus 1 into n factorial multiply by n factorial over n plus 1. This n factorial can be cancelled out. So we will be left with here limit n approaches to infinity n plus 3 divided by n plus 1 whole square. Now it can be written as limit n approaches to infinity, take this n common. We have here n plus 3 and here we have square term. So I can take common the square term. If I take square term common, it can be written as 1 over n plus 3 over n square divided by, take n square common from here, you will get here 1, you will get here 1 plus 1 over n. This n plus 1 whole square. It can be written as n into 1 plus 1 over n whole square. I just took the n common from this, and after opening this will separating it will become n square into 1 plus n whole square like this. So this will be cancelled. Apply the limit. This term goes to 0, this term goes to 0, so you will get here 0 over this answer, that is 0. And this is less than 1. So the given series converges. The given series converges by ratio test. An term is this whole term, that is an equals n cube e raised to power minus n4, and an plus 1 will be equals to n plus 1 whole cube e raised to power minus n plus 1 raised to power 4. Now using the ratio test, limit n approaches to infinity, an plus 1 divided by an. This will give you limit n approaches to infinity, n plus 1 whole cube into e raised to power minus n plus 1 raised to power 4 divided by n cube e raised to power minus n4. Now we can divide this n cube with this term. It can be written as limit n approaches to infinity, n plus 1 divided by n whole cube. And this term, we can move this term down and it can be written as into 1 over e raised to power. This term, if this power is moved down, it will become positive. It will become n plus 1 raised to power 4 minus n raised to power 4. Now limit n approaches to infinity, this will become 1 plus 1 over n raised to power 3. Now you need to open this term. This is n plus 1 raised to power 4. N plus 1 raised to power 4. It can be written as n plus 1 whole square into n plus 1 whole square. Now open this square term, that is n square plus 2n plus 1, and this one is n square plus 2n plus 1. Now multiply these terms. After multiplication, just substitute the values here and subtract it with n4. You will get here at the end you will get here 1 over e raised to power 4n cube plus 6n square plus 4n plus 1. And this term will goes to after applying the limit. After applying the limit, you will get here 0 in your answer. Because 1 over infinity will give you the 0, and 0 multiplied by this function will give you 0. And so 0 is less than 1. So the given series converges. By ratio test. Now question number 9 is n factorial whole square divided by 3n factorial. So an term is n factorial whole square divided by 3n factorial. So an plus 1 will become n plus 1 factorial whole square divided by 3 into n plus 1 will give you 3n plus 3 factorial. Using the ratio test, you will get limit n approaches to infinity, an plus 1 divided by an. This will give you limit n approaches to infinity, an plus 1 is n plus 1 factorial whole square divided by 3n plus 3 factorial. After simplification, changing the deviant sign to the multiplication, you will get here 3n factorial divided by n factorial whole square. Now open the terms, you will get here limit n approaches to infinity. Here you will get n plus 1 factorial into n plus 1 factorial like this. Divided by, open this one, you will get 3n plus 3 into 3n plus 2 into 3n plus 1 into 3n factorial. Multiply by this 3n factorial divided by n factorial whole square. This 3n and this 3n factorial will be cancelled out. Now this n factorial can be written as n square, can be written as n factorial into n factorial because it was a square. Okay, now we need to just simplify this numerator with this denominator. Limit n approaches to infinity, open this one. You will get n plus 1 into n factorial. And you will get here again n plus 1 into n factorial divided with 3n plus 3 into 3n plus 2 into 3n plus 1 here. 1 over n factorial and n factorial. This n factorial and this n factorial can be cancelled out. So we will be left with limit n approaches to infinity, n plus 1 whole square divided by 3n plus 3 into 3n plus 2 into 3n plus 1. Now we have 1, this n, this one and this one. 3 times we have this n multiplying with each other. So the highest power here is n cube. So I can take the n cube common. It can be written as, I can take, just open this n plus 1 whole square. This will be equals to n square plus 2n plus 1. Now take n cube common from here. So it will be n cube into 1 over n plus 2 over n square plus 1 over n cube. divided by, after taking n common from every bracket and multiplying, you will get n cube. And here inside will be left with 3 plus 3 over n into 3 plus 2 over n into 3 plus 1 over n. This will be cancelled out. Now apply the limit here. This term goes to 0, this term goes to 0, this term goes to 0. And 0 over anything will give you the 0 in your answer. And it is less than 1. So the given series converges by applying the ratio test here. Now the last question of this ratio test is question number 10. That is summation 1 to infinity n plus 2 factorial divided with 4 factorial n factorial 2 raised to power n. Here the term an is n plus 2 factorial divided by 4 factorial n factorial 2 raised to power n. And an plus 1 will give you n plus 3 factorial divided by 4 factorial n plus 1 factorial and 2 raised to power n plus 1. Now use the ratio test here. Limit n approaches to infinity, an plus 1 divided by an. This will give you limit n approaches to infinity, n plus 3 factorial divided with 4 factorial n plus 1 factorial 2 raised to power n plus 1 and 4 factorial n factorial 2 raised to power n over n plus 2 factorial here. Now simplify the terms. This 4 factorial can be cancelled out directly. We will get here limit n approaches to infinity. Now we have to open this one. Open the greater factorial up till this smaller factorial. N plus 3 into n plus 2 factorial divided with this n factorial can also be opened up to cancel out with this one. We will get here n plus 1 into n factorial. This 2 raised to power n plus 1 can be written as 2 into n, 2 raised to power n into 2. Multiply by n factorial 2 raised to power n over n plus 2 factorial. This one will be cancelled with this one. 2 raised to power n with 2 raised to power n. N factorial with n factorial. So we will be left with limit n approaches to infinity n plus 3 over 2 into n plus 1. Take n common and cancel with each other. The numerator and the denominator, you will get here 1 plus 3 over n over 2 into 1 plus 1 over n. Now after applying the limit, this term will goes to 0 and this term will goes to 0. So you will get here 1 plus 0 over 2 into 1 plus 0. So you will get here 1 over 2, that is less than 1. So the given series converges. Now in the next part, we will do the Cauchy's root test from question number 11 to question number 16.